Hey guys, in today's video we're going to be working on a Panasonic ToughPad. This is a rugged type of laptop tablet device. It's something I use for automotive diagnostics. I picked this up off of eBay and it has a BIOS password on it, and I'm going to show you how we can get rid of that. First, let me show you what the problem is. If I come in here into Update in Security and go into Recovery and then go into Advanced Startup, I'll show you what it means when it says when something says it has a BIOS password lock on it or something of that nature. So as soon as she goes and reboots here, we'll go into the screen where you could access the UEFI BIOS, and we'll see what happens when that pops up. So this guy's going to come up here, and we're going to say we want to troubleshoot, and we want to go into Advanced Options, and we want to go into UEFI firmware settings. And when we do this, we'll restart the tablet. Again, this is running Windows 10 on this particular. This is a Mark I ToughPad FZ-G1 series. And now we see we've got a password to get into the BIOS, which we don't know because the seller didn't know what it was. So that's what this video is about today, how to clear this BIOS password when you don't know what it is. So let's get it back into Windows and let me show you how you can begin doing that. Okay, we're back into Windows, and what I'm going to do is I'm going to install a USB key onto this guy. And that key is going to have some utility programs on it that we're going to use for this process. All right, guys, after you get that USB key or whatever, in my case, it's a USB key, you've downloaded this file somewhere else. I'm going to put links in the description for all these tools. But this AMI, this American Megatrends firmware update utility is what we're going to be working with first. So I've already unzipped that, and this is an Aptio 4 type of BIOS on this ToughPad. This is a Mark I FZ-G1 type of ToughPad. But we're going to go into the Windows version of this tool. And all we're using this tool for, 64-bit, because we're on Windows 10 64-bit. There will be another zip file in here that I've already unzipped. Again, when you download this from AMI, it's just one big zip file of a bunch of different utilities, and we're just drilling into the Windows 64-bit version of that utility. AFU Win GUI x64, we're going to run that. Going to get a access control pop-up that you need to say yes to, and it'll pop you into this. First thing I'll point out here is you have to be sure that it's the 30903.1462 version of this program. You don't want to have anything newer. You don't want to have anything older. All we're going to use this firmware update utility for is to save an image of the current BIOS. So we're just going to come down here and we're going to tap the Save button. And we're going to pick a file name. So in this case, I'm just going to pick locked.rom. How about that? It's going to go through its thing. You'll be able to see the progress of all the blocks of the flash chip being stored to that file. When it's done, we're done with that file. We can exit this utility. We can also go back to the root of this flash drive, and we're going to run the second utility. All right, so the second utility we're going to run, and again, I'll put a link to this one as well. This is an open source type of tool, and it's called UEFI tool. Actually, I'm going to go ahead and move the file that was saved because I'm just realizing I did not select where I wanted it to go. So let's drop it in here. And now when we go back to our flash drive, we'll have it sitting right here where we need it. After we copy that file, we're going to run this UEFI tool. This is an open source tool that I'll also provide a link to in the description. Just going to tap him correctly. Go here. I'm going to open the image of that file that we saved with the other tool that we copied over to our flash drive here. Let it churn on this. Just give it a moment to read it in. There she goes. All right. Open this up a little bit so you guys can see. I'm going to open up this UEFI image, and we're going to open up the first twisty and the second twisty. These are both the NVRAM areas of the BIOS, and this is where we're going to find where the password or passwords, if it's both user and supervisor, have been stored. And we're going to scroll down in this section here until we find a particular area. Just give me a moment to scroll down to the area of interest. Probably should have hooked a mouse up here. There we go. So what I want here is this area called AMI TSE Setup. So I'll pull this up a little bit more so you guys can see it. And now that I've got this selected, what I want to do is I want to view this particular area of the BIOS. And actually, I think I just have to long press on it without a mouse here. Hex view. There we go. And what I'm looking at here is an example of where there's both an user and a supervisor type password entered. The first password I'm going to look at is the supervisor password because that's near the bottom here. So this 66B hex value that you see here, if we count back 64 positions on this all the way back, it's just not going to select the way I'd like with the stylus, unfortunately. Trying. There we go. That right there is the supervisor password in an encrypted format, mind you, for this particular ToughPad. The one above it at the next 60B value and then 64 back, which I believe is right there, would be the user password. So sometimes you might only see the supervisor password populated. Sometimes you're going to see both of them populated, like in this case. Sometimes you're going to see the user password populated. The one it won't be populated will be all zeros. So the technique that we're going to do here is we're going to zero out these values and update the flash chip, and that's going to remove the password. Now, the method I'm doing here is specifically for the ToughPad. It's inspired from an earlier Panasonic product, the ToughBook, which is a laptop rather than a tablet, which also stores its password information in this same general area, but it's not encrypted. So it's an easier job on these older ToughBooks because what you would have here, you just have to exclusively OR with a key value, and there's the password in clear text. And I'll actually include a link in the description if you're interested in the theory behind that, but you can't use that technique on a ToughPad. On the ToughPad, this is encrypted, so you can't get back to the password, so the only thing you can do is remove it by zeroing it out in the actual flash chip. All right, guys, so now what we've done is we've taken the AMI tool for the Aptio 4 type BIOS and we've saved an image. And we've used the UEFI tool to go into the section of that BIOS that's known to contain the password, both the user password and the supervisory password. And now what we're going to do is take the version of that file that we saved, now that we know the string that we're looking for, and we're just going to pull up a hex editor. And by pulling up a hex editor, we're then just going to open up a file dialog, and we're going to pull up that same image. And now what we'll be able to do is we'll be able to search for the password now that we know what the string is. And hopefully this guy will pop up from where I typed it in earlier. Yep, just to save us some typing. And now, zoom in a little bit here. We have that same string that we saw before, but now it's in a tool where we can actually edit it. And that's the idea we want to do here. So this is the beginning, 5B, BF, B6, 9, B11. For this particular ToughPad, this is always going to be something different. But for this particular ToughPad, that's the beginning of the user password. Now this is the first copy. I'm going to show you there's a second copy elsewhere. So the first thing we're going to do, though, is we're going to kind of get away from our search thing here. And then we're going to go in and we're going to start editing this. And what we're going to do is we're going to edit out this entire password. So if we were to remember what we had typed in earlier and start going down here, right, we had the 5B, BF, B6, 9, 8, 11 that I just zeroed out. And now we've got the B3, 6C, 09, C7, D5, 22, 38, 7D, 22, D8, E4, 33, E. So we're just going to keep going through all of these, right, until we get to the end. And remember, the end is signified by that DB D0 value. So just going to keep going till we get to that 606B value, excuse me. And at this point, right here, we've now zeroed out the user password. There's two more left, the 60 and the 6B, right? So 1, 2. Now we're done. Now the 5B16 is the beginning of this particular ToughPad's supervisor password. So next thing we're going to do is we're going to zero that out as well. So just going to come through here and zero all this value out. Again, this is the encrypted password for the supervisor. We already did the user. And we're again going to look for that ending sequence of 606B. I keep misreading that when I'm looking over here at this screenshot. There it is, coming up on the next line. Right. There's the last two character sequences, 606B. At this point, we have now zeroed out both the user and the supervisor password in the first storage location. So what we're going to do is we're going to go ahead and save this. And then we're going to search again. And now here's the second copy. Remember I said there are two copies of this same exact pair of passwords. And like I said earlier when we were looking at it with the UEFI tool, you may only have a user password, in which case you only have the first area filled in. You may only have a supervisor password, in which case you only have the second area filled in. This particular ToughPad has got both of them filled in. So again, just like we did before, we're going to come up here and we're going to start zeroing this out. Make sure we didn't accidentally have that happen. So 0, 0. And we're going to keep going all the way until we get to 606B. So we're zeroing out the user password again. And again, we're doing this because on a ToughPad, these passwords are encrypted, so there's no way possible to figure out what they were. Right when I come down here, I've now done the user password. So now I've got the second copy of the supervisor password. Notice it's exactly the same string that we had before, 5B16, B6, 3B11, blah, 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 blah. We're going to go through and zero the second copy out as well. If we don't zero out both copies, one's a backup, and what you'll find is that the BIOS will just overwrite the one you deleted with the backup, and you'll be right back in the same problem again. So now we're zeroing out the second copy of the supervisor password. And there's our last two, 606B. At this point, we're done, and we save. Now, if I were to exit out of this tool and pull it up again and reopen that file, see if I can make this a little bigger. through my search again. Type in my same string. Can't find it. The reason I can't find it is it's gone. So we've overwritten it. So now what are we going to do? Well, you technically, in some situations, you could take a file like this and use that same AMI BIOS tool to write it back. But I don't trust these Windows type of tools. So what I'm actually going to do is this same kind of procedure I just showed you here, but at the board level. I'm going to open the ToughPad up. I'm going to remove the BIOS chip. I'm going to read it. I'm going to save it, and I'm going to edit it just like we showed here, and then I'm going to write it back using a flash programmer and then resolder it back to the board and boot it back up. That is, to me, the sure way to avoid any hassles or problems. If I had a backup copy of the the flash chip, then I might be inclined to try using the AMI tool to do this, knowing that if it bricked it, I had a way to get back and recover, but I don't. This is the only ToughPad I've got. So that's the technique I'm going to be using. But I showed you a lot of this so you can get the background theory. What I'm going to do now is I'm going to go ahead and proceed to disassembling this guy. So I'm going to go ahead and shut him down. And then we'll go ahead and start taking it apart. Let me show you that next. All right, guys, to disassemble one of these ToughPads, the first thing we're going to remove, this particular model has one of these wrist straps. And so we're going to need to get a Phillips screwdriver and remove the 4 Phillips screws in each corner that are securing this guy. There's like a bracket on here. And then once you get these guys off, this kind of comes off like that. We're just going to proceed to do all 4 of these. And then we'll come back and continue. All right, once you get the last screw out holding this wrist retainer in place, you can just remove this along with its little brackets and set it aside somewhere. And then the next thing you're going to do is remove the corner bumpers, and they're held in by a single Phillips head screw in each corner. Once you take that off, they come right off like you just saw me do that one there. So let's go ahead and remove the other 2 and come back. When you get down to do the one in the lower right here, because that's also where the charging jack is, we'll also have to remove this screw right here that's securing the charging jack into position. A little bit smaller. That one's in there nice and tough. Tough screw in the ToughPad. All right, so get that guy out. Then we can get this little plate off. Right, this little plate comes off. And then the little door comes off for the charge port. And then we can remove the bumper. All right, so now with the bumpers all off, the next thing we're going to do is we're going to remove this stylus. We're just going to take it out of the way because there's some screws in here. And we're going to remove the battery. So on the battery, zoom in here so you guys can see. So the battery's got a position that has a lock on it. Just slide that up and out, and then you can lift the battery out of the unit. Once you do that little latch, it just comes right off. We'll set that aside. And by the way, there's a recall on these batteries for these Mark 1s, so you want to make sure you don't have one that's subject to that. Those all should have died by now, but just in case, I'll keep a link to that in the description as well. Okay, so now we're going to remove the screws that are retaining this guy. And we'll start with these guys right here on the bottom. So there's 4 screws that run along the bottom here, 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 and here. We're going to remove those 4 and come back. All right, guys, after you get the 4 on the bottom out, you remove the 2 that are recessed here and here. And then after you get those 2 out, you start to remove the 2 that are recessed here and here. We'll get those and come back. All right, at this point, the only screws we've got left are along this side. So there's 1, 2, 3 inside where the stylus goes. So grab this one in the middle first. This one up on the top. And this one near the bottom. Now that should be, unless we missed something, that should be all of them. Plug our stylus back in so it doesn't wobble around. This might not have ever been opened before, so it might be a little stiff. Or we might have missed a screw. I don't think we missed a screw. I think she's just stiff. Yeah, there she goes. All right. So the top is off. Sides are off. Bottom's still clinging on. This kind of stuff you just want to be patient in case you did miss something. I can feel it slowly letting go. Yep, it's just old. Just old. All right. So what I'm going to do is I'm going to take my little magnetic sheet with the screws and find a new home for it so we can open this guy up. Okay, now we got some room. I'm going to flip her around so that we got the top facing the bottom, and then we're just going to open it up. And the reason we did that is there's some ribbon cables here that we don't want to damage. All right, now we're just going to roll it back around like this. And the next thing we're going to need to get out of the way is this fan. So that fan is held in by a couple more Phillips screws. One here. One here. And one here. One, 2, and 3. Just going to gently pick it up. Okay, so we just want to get that out of the way. We don't need to remove it. Now the guy we're after, got to get this little plate off of here next. The guy we're after is right under here. So I'm taking this little screw here off. I'm going to take this little screw here off. See if that gives me access to this little silver plate here. does. Okay. All right, so now we're just trying to see how it's secured here. I see another screw right there. So I haven't opened one of these ToughPads before, but I've done plenty of these flash chip updates, so it's just a matter of figuring out how this guy's assembled and getting the access. All right, so wiring is kind of wrapped around this guy. I think we can just kind of push him over here for now. So this plastic covering is the last thing we've got here, guys. All right, so I can see our chip. It's right there. But we've got some kind of clear plastic insulation down here, and I just need to see about how that might be removed. I mean, just because it's a ToughPad, right? It's got this on here to help protect the board. What I might do is just cut this so I can get access, but let me spend a little bit of time and see if I can remove this without damaging it, because that would be my preference. Now guys, nope, there is no way around this. I think what I've decided I want to do is I want to keep it, you know, as original as I can, but I also need to get in here and do what I need to get in here and do. So I'm going to lift this up just a little bit. Give a cut there. Tape that back. We can tape that back. So what that's going to do is it's going to give us access to the BIOS chip, which is this guy right here with the paint mark on him. Right there. Little 8-pin guy. Yeah. That guy right there. I don't know if the camera will zoom in anymore. Nope. And what that is actually, what that looks like, I think I have one here. It's just a 25 series flash chip. All right, guys, just a little bit of background on the chip that's used on this board. It's a Micron serial NOR flash memory. N25Q128A family. If we look at these sheets, these pages from the data sheet, just a couple of pages that are relevant, right? We can see the pinout of the chip. And when we look at it on the board, pin 1's in the lower left because it's oriented in this direction on the board. And we can see what our pins are here, or maybe you can't see. Let's kind of zoom in a little bit. But these are the pins 1, 2, 3, 4 on the bottom, with ground being on pin 4, power being in the upper left, 8, 7, 6, 5. So that's the pinout. And then the part numbering scheme for this. So the one that we have on the board is a 28Q. Let's see, what's our picture here? Yeah, it's a 28Q 128A on the first row. And then on the second row, it's a 13EC0. And if we go decode that here, we can see N25, so the N's implicit. So even though we don't see it on the chip, we can add it implicitly. We've got our 128 for 128 megabytes. A is the size. Make this just a little bit bigger there. And then we've got a... so that covers us here. So N28Q128A, and then we got a 13. So we can see that the 1 is for the byte addressability, and the 3 is for the voltage range. And then that covers us up. Now we've got an EC0. Well, the E is for uniform sizing. I guess they're all the same there. The packaging is implicit. It doesn't say just like the N, but what we have is an SE. We got an SOP 28 in a 200 mil wide body. That's going to be important later for the type of socket that it fits in. And then we don't see, what we don't see is the C0. So the C is a temperature range, and I'm guessing for Panasonic, being this is a ToughBook, it's probably some special mil-spec type of temperature range. It's not on the data sheet normally, and then of course we have the security features as a 0 and the shipping material you'd only see on the box. Normally, to replace this, if you have to replace it, you'd find more readily available an E40. And that 4 maps over to just this standard temperature range here, minus 40 to plus 85 degrees Celsius. So that's just a little bit of info on what the chip is and its numbering and packaging. All right, so that's kind of like what we're trying to chase in here. Just one of these guys. In fact, what this is this is a pre-programmed flash chip from a different FZ-G1 ToughPad. In the event something goes wrong, I've got a backup. It's not going to have the right serial number, and it's not going to have the right model number as this one, but it's something to have as a backup. And in fact, if you prefer, I'll put a link in the description. There are places that just sell you those kind of things pre-programmed that you can solder right in. All right, so what I'm going to do now is I'm going to get these 2 pieces of plastic taped back and out of the way. We'll move this guy under the microscope so you can see what I'm going to do. But basically what we're going to do is going to use some low melt solder using a product I use for that purpose, because we don't want to get a lot of heat on this. Not want to use the hot air gun. We'll destroy the rest of this. We're going to use some Chip Quick SMD1. Just going to put some low melt solder on there. We'll pop this guy off in less than 60 seconds. We'll pop him into an EEPROM reader. We'll read and save the image just like we showed earlier from the Windows tool. And then we will zero out that user password area, that supervisor password area, and then we'll rewrite it back and we'll resolder this guy back in, and we should be in business. So let's go check it out and see if that's the case. All right, guys, at this point, I've just got some Capcom tape and we've cleared this guy off. Let me give you a view in the microscope now. All right, guys, here's our chip, our 25Q128. Just going to turn our extractor on. Going to put a little bit of flux on this guy, and then we'll pop him right off. Let's get ourselves some low melt solder. Over here and get our iron. Once this contaminates the no lead solder that's already on there from the factory, she'll let go. This way we're not using any hot air or anything like that. Okay, so she's letting go. Well, I didn't grab my tweezers fast enough, guys. There she goes. All right, we'll clean this up and we'll get it into an EEPROM reader and we'll see what's on it. All right, guys, now that we've got our chip out, we're going to put it in a programmer and read it. First, a little thing about sockets, right? So this type of 25 flash is not going to fit in a standard SoC8 type socket. This chip's going to be too wide. So you have to have one of these wider type of SOP8 sockets, right? Something in the order of 200 plus millimeters in width for this guy to fit. And we're just going to take our chip and put him inside the socket. You just kind of push down, work this guy in like that, and then lift up. Now it's convenient that Panasonic put a little paint mark right on the top here where the dimple is that signifies pin 1. Right, so that's important to get pin 1 lined up properly when you put it into the programming socket, and of course get the socket lined up properly on whatever the programmer you're using. In the case of this TL866-2 Plus, it's in this orientation here with pin 1 right here in the upper left. All right, now that we've got the chip mounted and we've got it in the right position, let's go ahead and give it a read. All right, guys, after we got the chip in the socket, we can go back to the software that's driving the programmer. Like I said, in this case, I'm using a TL866-2 Plus by the Auto Electric Company, and they have this software called XG Pro, and I'm using version 11.6. XG Pro has an ability to detect the type of flash chip that you've got in the socket, which is a handy feature if you're not sure who the manufacturer is. So we can use that feature to pull up and give it a detect, and it'll come down with a drop-down list of choices. We know this is a micron just from the format of the part number, but if we didn't, we might be able to get some other clues. We can hit select on that, then we can come up to device and we can give it a read. Now the read on this device is going to go pretty slowly just because of the size. Let me pull this up where you guys can see it, and I'm going to click the read button. So we successfully detected it okay, and now it's reading the device in. So you can see it's chugging along here, reading in everything on that. And this is why I trust this approach better than the Windows tool, because I can be sure that everything on the bare metal is getting read in at this point. And no interference from any Windows drivers and no potential areas of the chip that are neglected and left out. We're getting every single bit with this approach. So just getting near the end here. Okay, done. First thing we want to do before we do anything else is we want to save this so that we have a backup copy. Hit File, I'm going to hit Save. I'm going to pick a location to store this in. I'm going to just pick Downloads here for a second. I've got an old copy that I've done before there. We're going to say that this is an F1 locked BIOS image, and we're going to tell it that it's a binary. We're going to hit Save, and then we're going to have to hit the Save As button. Now it tells us that it has been saved. We hit OK. So now we've got a couple of choices. We can either try to edit this directly in the programming editor, or we can go edit it in our separate HexD editor. If we try to edit it here, there is a find feature on this particular EEPROM programmer interface. Not all of them are going to have this. And then what we can use is we can go back to our screenshot, and we can copy in some of the characters that will give us a match of the user ID, user password. So 5BBF B6, 5BBF B6 9B. That should be enough to get a hit. We're going to search on hex, and we're going to hit find. Now this particular search on this thing is super slow. At the bottom of the screen here, there's a little searching message. Otherwise, you wouldn't have any idea that it's doing anything or that it's hung. But it is searching, and this is why you might want to use an editor outside of this to do what you need to do here. But here we are. We got the first hit in the first NVRAM area. It's a lot more easier than before when we had that stylus. All right, and so just like before, now we've got this whole area down to here is the user password. So from the first 5B, BF, B6, 9B, 11, B3, 6C09, C7, we know that's the first sequence. And again, guys, I want to stress, your ToughPad is going to be different more than likely, because this is the encrypted hashed password that this particular one had. Depending on what was typed in as plain text, the password, the string of characters is going to be different. All I can tell you is it's going to start with a 5B, and it's going to end with a 606B. This is the user password area again. If this were zeroed out, it would mean there is no user password, and then we would look down here at the 5B starting right after that, which is the beginning of the supervisor password. And that guy's going to run all the way until we see the next 606B sequence. So if we go do that and we highlight that one, the supervisor password, that one's going to run all the way down to here. And that would be the supervisor password. And again, this one could be zeroed out and only the user password showing on yours, or vice versa. Or in this, like in this case, they're both there. So we can directly edit this in here. So I can come back up here, starting at the beginning of the user password, and I can begin to zero all this out. Just like we were showing earlier. But now we're directly editing the image that we're going to write to the EEPROM chip. Excuse me, the flash chip. All right, so at this point, right here, when we wipe out the 606B, and now we've gotten rid of the user password. If we keep going, we'll get rid of the supervisor password. Just be careful that you do not go beyond the 606B. That 01 starts another very important sequence that you don't want to disturb. So at this point, we've gotten rid of the first copy of both the user and supervisor passwords in memory. Now we're going to go back up and we're going to hit Find Next. Now we've got our second copy. Remember, there's two copies like we saw in the UEFI tool at the very beginning of the video. There's two copies of this NVRAM area. So now we need to zero out the second one. And again, double check that you've got the right hit. So we've got a 5B BFB6, 9B 11B3, 6C 09C7, right? That enough of a sequence is enough to tell me this is ours. We're going to go ahead and zero this out until we get to the 606B. 606B. That's the user password. Now the beginning of the second copy of the supervisor password. Same thing. We're going to go zero this out until we get to the 606B. 606B erased, and now there's an 01. At this point, both copies of the password have been erased. In this point, we can write it directly to the chip at this point, or we can save this and we can go double check it with another editor if we want to do that. I'm comfortable enough with this editor that I'm going to go ahead and write it, but I will save a copy just in case. So in this case, I'm going to save it to the same location, but this one I'm going to say is unlocked. No password. Hit that, and now pull this in here so you guys see the message. Now we've saved the no password version, right? So at this point, we'll do one more check to make sure there's no instances of this string. It's going to go through and search the whole thing and wrap around, but just to be sure. And again, it's excruciatingly slow, guys. But we can see at the bottom, very bottom next to the ready, there's a little status message area of XG Pro, and you can see it has the word searching in it, so you know it's doing something. And we'll just wait for it to do its thing, go through the entire flash image, looking for that sequence, and make sure that we get this message back, that it can't find another instance of it. At this point, we're ready to program the device. So we're going to come over here, and we're going to say Device, Program. Okay, at this point, we're reprogramming the device with the exact same flash image, but now with those password fields blanked out. It's going to take about as much time. It's going to take a little bit longer than the time it took to read it because it has to first erase the flash before it can reprogram the flash. So it's on the erase step right now. And again, depending on the type of programmer that you're using, yours may be slower than this, yours may be faster than this. They're all a little different. We just have to be patient and wait for it to do its thing. Now, as soon as this is done, we can go over and solder the chip back on the board, and we can fire it up and make sure that we're good to go. So we're coming near the end of the erase step here. It's lots and lots of patience, guys. And I'm showing you all this without editing it out so that you can see what you should expect if you're using these same tools. A lot of times you see a video and people will click a button and then boom, next thing they're done, and you don't know, was this supposed to take that long? Was it supposed to be that long? And so this way you guys can see exactly how long it's supposed to take. All right, so we're on the second pass of programming, second step rather, of the programming step. And again, just to show you this is how long this particular process is going to take, so you know what to expect. So she's going to chug along for a little bit longer. gotta love some of the translation errors here. Like I love view the adapter. Missing a little A there. All right, we're about halfway through this second phase of the programming step. And right after this finishes, yeah, there she goes. Now she's actually doing the programming. So we'll see a little percent meter at the bottom. Now that the erase is done, 10%, 12%, right? You guys can see it right down here, hopefully. Looks like you can. About coming up a fifth of the way. Quarter of the way. It speeds up as she has more blank areas that don't require anything to really be written. We're up halfway now. It's going to speed up a little bit more. There's a lot of blank areas towards the back of this particular chip on this particular image. So the speed's picking up. Coming up on 3/4 of the way. And then at the end of this, I'm not really sure if it's going to do a verify, but even if it does, we're going to do a manual one just to be super sure that we've got what we want in here. All right, 95%, 5% left, and she's done. Now she is doing a verify. Okay, so now we're going to verify what we've programmed to the chip matches the edited copy that we have in the buffer. That's coming up much faster. And then after this is done, this step with the programming device will be done. Okay, success. We're all done here. So I'm going to hit the back button. And I mentioned before I'm going to do a manual verify because I want to be super sure that we have what we want to have here. We're going to do all this effort and solder it back together. We want it to be what we want it to be. So we're now going to do a manual verify. That's going to run the same as the verify step at the end of the programming script that ran before, but just to be super sure. Couple more seconds here, just so you guys can see what to expect. So you're going to be investing about 10 minutes of your time on this part of the process alone, just because of the speed of the programming tools. All right, we're done. So at this point, we're all set. And I did tell you I was going to show you an alternative way. I won't go through the alternative way completely, but you could just as easily have come up here into the hex edit tool, and you could have came down and you could have opened that file that we originally saved of the locked version, right? So the locked BIOS, we could have pulled this open. We could have came in here. We could have done that same search that we talked about earlier. 5B, BF, B6. I'm just looking at my screenshot here because I can just never remember this sequence of characters. All right, and we go hit our search here. And you notice that's super fast compared to the other tool in terms of finding this. And then, you know, we could have come down here. Let's pull this up. Well, I scrolled past it, guys. Let me go back to it again. There. We could have came down here and edited it in this editor, just like we just did in the programmer's built-in editor. And we could have erased both copies, saved it, pulled this version of the file up into the programmer, and wrote it that way. So there's two different ways you could have attacked this particular problem. At this point, we're done. We're ready to remove the chip from the socket and solder it back on the board. All right, guys, you can see we've got our pads all cleaned up and ready to take our chip. Not necessarily going to bore you guys with soldering it back on, but we'll get it soldered back on, and then we'll get it buttoned up and see how she works. All right, guys, at this point, we've got our chip sitting in the flux, ready to solder in. You'll notice that the yellow painted dimple for pin 1 is in the correct orientation. There's a little triangle on the printed circuit board you can see that also indicates 0.1 there in the lower left corner. All right, guys, we've got the chip soldered back in, and we've put some Capcom tape over to repair where we had to cut the covering. We've restored this plate here, but this fan is pretty bad, so we're going to clean this up while we're in here before we button it up and test it. All right, guys, as we put the cover, the digitizer cover back onto the base, we just want to make sure that we're not pinching these ribbon cables down here. Just make sure we're not pinching those. And then we're just going to put a couple of fasteners on here just to hold it together while we do an initial test. Just one at the top and one at the bottom will be fine, I think. just in case, you know, we accidentally drop it or something like that. We don't want to have the two pieces come flying off, and then that might result in some damage to those same digitizer cables I just mentioned. So a couple of them. And then the next thing we're going to do, just really quick, we're going to make sure we've got a good power supply for this test. Just going to run our positive lead inside the barrel, and we're going to test the wide band at 15 and the narrow band at 16. So we got good voltage on our power supply. You don't need a battery for this kind of smoke test. We'll just come up here and install the, upside down. Just install this guy like that. And then we'll go ahead and power them on. That's good. We passed the smoke test. So obviously we won't get a light on the battery because there's not one installed. If you don't get a green power on light, that usually indicates that you've either soldered the flash chip on incorrectly or you haven't burned it correctly. But this type of laptop or tablet, if the BIOS chip is no good, it'll abort the power on sequence. You won't even get the LED to light up. All right, let's just wait and make sure Windows comes up okay, and then we'll go and verify that we've got the BIOS password off. So we're going to log into Windows, and then after we get logged into Windows, we're going to go into Settings, Update and Security, Recovery, Advanced Setup. Going to let her restart. This is the same test we did at the beginning of the video that showed it was locked. We're going to use the same test to show that it's not locked. She takes a minute, and then we'll come up to this screen. We're going to go Troubleshoot, Advanced Options, UEFI Firmware Settings, Restart. And this time, we should come right into the BIOS unless we screwed something up. Voila. No password, guys. So she's all done. The only other thing I'm going to do, you notice that the BIOS configuration version on here, version 1.00L20, I mentioned that I do have a updated BIOS. So I'm going to get out of this, and I'm going to go apply that updated BIOS. And that's going to be the last test that I end up doing. So first, we'll go ahead and restart this guy and get back into Windows. And then I'm not going to save all that for you, right? I'll go into Windows and we'll show the flash, and then we'll come back. All right, guys. Like I mentioned, this step's optional. I'm going to go into BIOS Update, and we're going to run the BIOS Updater program that we downloaded. This particular one didn't have the latest BIOS, so it's another great test that we can do to make sure that everything's happy with the edits that we made. So it tells you you currently have 1020. Let me see if I can get this in here where you guys can see. You currently have 1020, which we saw, and it's going to update us to 1024. So we're going to go ahead and do that. So this particular program wants the battery installed. All right, let's grab the battery and then we'll rerun. All right, guys, let's try this again. I went ahead and put the battery in, and since I had to put the battery in, I just went ahead and did the reassembly of all the other fasteners. This time it should be happy because we've got a battery installed. So now we're going to go ahead and update that BIOS. We just want to see that something like this is successful. It's totally optional, of course. You don't have to do it. But since we have the ability to do it, it's a nice additional test. And there she goes. So the fact that this is successfully updating tells me that we're totally good to go. If you didn't have this step, you could just go through the options and do some changes of BIOS settings and make sure that it saved and took to know that you were good to go. Anyway, that's it, guys. I hope all of this detail helps you out on disassembly. 2 different types of methods for figuring out what you need to edit, where you need to edit, how to do the editing, how to do the programming, information on the flash chip itself, and then how we can go do these final tests. All right, guys, as we can see, We're back inside the BIOS menu, and the update was successful. So we are done. Thumbs up on this work. A lot of detail, a lot of info in here. How about you take a moment and hit that like button to see how it helps you, and give me that feedback that these are the kind of videos you enjoy watching. Think about hitting that thanks button if I saved you some money or time. And as always, thanks for watching.